Well, hello. Because of Corona, we cannot do that directly at the steam engine, so we will do our episodes from the workshop now with the materials coming from the education of people working on steam locomotives, like that one over here. And we today have the same of having how an water steam injector will work. And because of that, we have to first look out on the first thing, which is in the line of the boiler, and this is the boiler top clock or the boiler check valve. This is the main check valve which will prevent any steam flow back from the boiler to our feed pump, or here the injector. First of all, we have the boiler connection over here, and then we have a hand valve. This is important and needed because we always need manually to shut off that boiler opening. And then behind we have that casing over here which houses the check valve over here. We can see in a cross section, and it is of details of the housing or casing of the valve and the valve body itself. The valve body itself is a hollow cylinder with a cone-shaped bottom, and the hollow cylinder also has many holes so that water can not also move around it. It can also flush back into it, and then from there go into the boiler. So if our boiler feed pump will pump water in here, then it will put a pressure on the seat over here and on the bottom of the valve body, lift it from its seat of the casing, and then water will rush around here by the casing and into by these holes into the valve body, and then moving into the boiler itself. And because it's a check valve, steam, if no water will pushing against it, steam will now return here, coming here to that seat and push down that valve bottom over here into its seat, and so will shut off the boiler from the feed line. This is what the check valve usually does. And because of those materials are of bronze, they usually wear out. Little parts within the water and also can damage the seat and the seal surface between the valve body bottom and the casing seal seat over here, and so we have to remove that valve body and machine the seat, and also maybe machine the seat in the casing. And because of that, which is much maintenance, usually there are reconstructions which have a PFTE part over here and a flat surface and not the cone-shaped surface anymore. Also, there are changes with it never come, which came with the Federal Railways, which used a plate-shaped non-return valve, which was spring-loaded to have it in place and controlled it into its seat. Because we don't want to discuss this further, we only need to understand that the boiler pressure will push down that valve body into its seat with 16 kilograms per square centimeter, and so shut off the boiler from the feed line. And we have to determine how the injector can open that valve. And that's what we're going now. Well, because our theme is the injector, we cannot go to the original, which is located at our steam locomotive in the shed. So we have to stay on the education manuals, and we here have a Friedmann non-self self-priming injector. We have non-self-priming and self-priming injectors, and the Friedmanns are from Austria, and usually the most of them are self-priming. Self-priming means it does not need a special vacuum build-up because the water is flowing by gravity into the injector. So we can find those self-priming injectors usually located lower than the cap floor, so that water from the tender can flow freely into the injector and fill the water chambers. So how is an injector working? Because we have the live steam entry, the water connection, and here we have the pressure line for the boiler. So we have, that's the water feed line. We have a watercock. We have the so-called schlubber, which means that's the overflow. We have a pressure valve, and we have a non-hammer valve. So how does that work? Because if we came here with a pressure of 16 kilograms per square centimeter, how can we open our check valve, which we have seen before, which is also pushed down by the boiler pressure with 16 kilograms per square inch? How can we go there? Well, this has to do with the Venturi effect. Mr. Venturi found that if we have a large diameter of a flowing media like liquid, we have a high pressure but a low speed. If we constrict that tube, we will have a lower pressure in the constricted area but a higher speed. That's what it makes to a nozzle. A nozzle will transfer a pressure into speed. We usually think that this is pressure what we can estimate, like on a garden hose, when the water will leave the nozzle on the garden hose. We usually think this is pressure. No, it's speed. A nozzle will increase the speed. And so we have a set of nozzles inside our injector. So we have the first nozzle over here, which is the steam nozzle. Then we have a mixing nozzle, and then the magic happens over here in the Venturi nozzle. So how does that work? Well, if we open the water cock, which is over here, so the water will flow into our injector and fill that water or mixing chamber. Now we open live steam, and the steam will now enter this nozzle, and the pressure will be dropping by that nozzle to the point where it leaves and has a higher speed but a lower pressure. Now it enters the mixing nozzle, and because of the principles of dynamics, it will now draw water from the openings here, the openings here, and the openings here into the stream of water, and then go into the Venturi nozzle. The Venturi nozzle we see over here is from constricted to a wider opening, so speed at that point will be crucial. If the speed here isn't at a given amount or given level, the widening here won't transfer that speed into pressure, so it cannot open that pressure valve. And because it cannot open the pressure valve, the water cannot go through that Venturi nozzle. It remains over here into that point. And so we have exit holes over here in that mixing nozzle, and this will drain or push back the water into the overflow, opening that little flowback valve over there, and from there it can move into the opening. But the self-priming injectors have the advantage they don't need really to prime. As the steam starts into the steam nozzle and is fully opened, it will just move by full force, and now the magic happens. Because it takes on water, steam will condensate, also steam bubbles will mix into the water, so we have an increase not only in speed because of the constriction of that nozzles, we have also an increase in volume. And because we have an increase in volume, more speed is generated. It's important to understand that with the mixing of steam and water and the increase of volume of the mix of steam and water inside the mixing nozzle, we reach a very high speed at the end of the mixing nozzle. And this high speed now will enter the Venturi nozzle over here and gain a given critical or crucial speed at that point. And because the inverted cone of the Venturi nozzle now will transfer that speed into pressure. So it will slow down the force and the speed of our media and transfer that into a pressure, which then fills that space, opens the pressure valve, and from there going to the feed line to the boiler. And that's why we can go here with a low pressure and gain a higher pressure over here, and this pressure is also high enough to open the check valve we have seen previously. That's where the magic happens. This is the main part, the Venturi nozzle over there, which will transfer the speed of the media into the pressure, so with a lower pressure to a higher pressure over there. Not a magic, because of the increase of speed and the increase of volume, which is then transferred over here and over here by the Venturi nozzles into a pressure. Well, if we now shut off the live steam, the first thing what happens is that the pressure here drops, and so it shuts the pressure valve. Now, because of a pushback in pressure, the check valve here will be pushed open, giving it free to space so water can exit by that mixing chamber into the so-called schlubber chamber, and from there exit into the opening. And because we want to avoid a water hammer back into our water line, which is over here, we have that check valve over there, which will prevent a water hammer going back into the tender, and this will push now water back after the pressure in our mixing chamber, and the schlubber is equalized. It will also reopen again and then fill that space again, so the injector can restart easily. Now we're going to the non-self-priming injectors. Well, now we come to the non-self-priming injector. This is an injector of the German standard build and casing. It is built by the Strube company and usually was built for the Prussian railways before the German imperial railways pre and during World War II. And because of standardization during these times of the imperial railways, this Prussian injector was used as a standard or unified part of the steam locomotives. So we have here the steam valve, which is a spindle valve. We have the steam supply, the water supply, the water to cock. We have the steam nozzle, and we have the mixing nozzle, and we have over here the so-called Venturi nozzle and the pressure valve. And because then we have the feed line over here, which is the feed line of the water to the boiler. How does it work? Well, because no water is within our water space or water chamber. Because the injector is higher than the water table in the tender, we open the steam valve a little only. Now steam will enter by that cone into the steam nozzle and then produce by hitting this suction nozzle a negative pressure or vacuum in the water chamber. Now water is drawn from the tender reservoir into the water chamber. The water enters now the mixing nozzle and will be taken by steam into the mixing nozzle to our slobber chamber. Again, we call that slobber, it's an overflow which has an overflow check valve over here. And because we have a little steam from here and a little water only from the water chamber itself, that mix of water and steam in the mixing nozzle isn't enough to open the pressure valve and go into the feed line. So by small bores over here in the mixing nozzle, that mix of water and steam will enter the overflow chamber or Schlabberkammer and will open our slobber or overflow valve and drain into the free air. And because of the steam and water mixing over here, we will have an increase in volume. The steam will condensate and mix with the water. Also steam bubbles will mix into the water and we have an increase in volume over here like we had before. And because of the constriction of the nozzle, the pressure will drop but the speed will rise. And because by the rise of the speed we can reach a crucial speed over here. Now we have the inverted Venturi nozzle, which will transfer that speed back into a pressure by reducing the speed, and thus we getting a higher pressure. And now the pressure valve over here can be pushed open and the pump begins to feed into the boiler. This is the minimum of delivery rate the pump can do. So if you open it and the pump will start feeding, this is the minimum. As more as we open now the steam valve over here, as more delivery rate of water into the boiler we get. And because we are opening now the pressure valve itself, the steam and water mix will go through the nozzles and also withdraw the volume of steam and water inside that overflow chamber or Schlabberkammer, and then it generates a vacuum inside here, pulling back the Schlabber ventil or Schlabber valve or overflow valve into its seat, sealing it from the outside, generating a vacuum inside here, and so the stream will flow freely through the pressure valve into the feed line. The pump is moving on the lowest delivery rate. Now we can open more of our steam valve and increase a steam flow over here, and increasing a steam flow will increase the speed, increase also the suction over here at the negative pressure, so more water is drawn into it and we reach more speed and more delivery rate into our boiler, and so we generate a higher pressure than we have here. So that pressure over here will overcome also the pressure of the main check valve at the boiler we have seen before and is able to open it. And now we have a flow, and with the steam valve we can adjust the delivery rate of the pump in a given range. What will happen when we shut down our speed pump? First we close the steam valve. So the cone will shut down the steam coming from here, moving into the steam nozzle, and so the steam will not flow anymore. The next thing is the rest of the flow will go through, but not all of it. So it will stop over here as the pressure will push back and close our pressure valve inside the pump. Now the water which is moving from here and cannot bypass the pressure valve will exit by the bores and holes into the overflow chamber or the Schlabberkammer. Open the overflow valve, open our Schlabber valve, and then from there it goes into the overflow, into the opening. And that's the remaining water from here and here moving just out into the free. And because the injector is located higher than the water table on the tender water, the water from here is only drawn into a little, not much, and so the pressure drops quickly and the water can flow freely back into the tender. And because of having now a free volume over here, we don't need any pressure relief valve, because there cannot be a water hammer inside that, because the water is just pushed back into the tender, and from there is enough volume to prevent any water hammer, so there is no extra valve over there. Yes, and if we see now that steam is coming by the drain, then again we have to check the boiler check valve. If steam is pushing back by the main feed line, and we have to check the pressure valve inside the pump. Maybe steam is leaking into our overflow chamber and from there leaking, or the steam valve over here isn't any more sealed enough and needs to be overhauled. To overhaul, we can open the flange over here and draw out our spindle with the steam nozzle cone, and then we can unscrew the steam nozzle to check the seat over here. Also, we can pull out the nozzles down to our pressure valve and then check it. Maybe there's some limestone in, or maybe it's damaged over it, and so we can just remove it. Usually the nozzles are screwed in, some of them are not screwed in. They have a sealing with some windings of sealing cord around it. Some of them also have ring seals over here, and there are different types because of the German Federal Railway, the Imperial Railway, as well as the railway of the former German Democratic Republic. All of them used a little bit different designs inside of it, and thus we have many injectors having a mixed design from different parts of the injector and different parts of the different railroads and different times. And so many of these injectors, sometimes it would be better if one injector, maybe from the German Federal Railway, will only be equipped with nozzles and steam valves from the Federal Railways, and not be tuned or used because you have it in spare with from the former German Democratic Railways steam valve. And so you have mixes, and those mixes usually can generate problems in maintenance. But now you know how the injector works, and again we will show it again. We open the steam valve a little, so we generate a vacuum inside the water chamber. Water is drawn into the water chamber from the tender and is mixing with the steam at the mixing nozzle, and then transferred into the mixing nozzle. Because increase in volume, because the steam condensates into water and adds water to the water which is drawn by the steam in. Also steam bubbles will go into solution into that water, and we have an increase in the volume, so the speed increases by the nozzle to the crucial point. As long as the speed isn't over the crucial speed, it will drain by the holes into the overflow, opening the overflow valve and draining into the open. As more that speed rises, as more we came to the crucial speed, and if we hit the crucial speed, the Venturi nozzle, which transfers the speed of the media back into pressure by reducing the speed, will open that pressure valve to the feed line, and the injector starts feeding. And because now it takes a vacuum over here, drawing back the overflow valve into its seat, sealing that space from the open air, and the flow of media is perfect in the direction of the boiler. And now we can open more the steam valve and increase vacuum over here and increase suction of water into the mixing nozzle, and thus increase feed rate of our injector. That's how it works. I hope you enjoy. Thanks for watching.